Configuring IPSec VPN, also known as site-to-site VPN. Going back to our GNS3 example, we built two different sites using FortiGate units. We have our original site and we have our new site, and we are looking into options to connect these two networks together. Right now, these two networks are not connected at all, and we have a variety of options on connecting different sites. The first option, we can purchase a circuit from a service provider, which can allow us to connect over the WAN over a private link. This can be very costly, and for redundancy, you have to pay twice that amount. Therefore, for a small or a new business, it might not be a viable option. And therefore, we can use a VPN tunnel to connect these two sites together over a secured channel where all the traffic traversing the internet between these two sites, it will be encrypted in transit. Therefore, it will be safe from man-in-the-middle attack and sniffing. Now let's see how we can build a VPN tunnel between these two sites. First, I'm looking into my new site. I see this is my internet port, and I want to emulate the same exact thing as a real internet connection. So I want to use this cloud interface on my GNS3, and the traffic will be flowing between this cloud and this cloud in between the firewalls to form an IPSec VPN. Let's see how we can do it. First, we need these IP addresses for our internet. This should be a public IP in the real situation, but in our lab we are using this private IP to emulate the internet access. On our original site, we have an IP address for the internet port as well. These are called VPN gateways or VPN endpoints. This is the IP that is facing the internet, and this is the IP that will be used to communicate with the host on the other side. So first, let's go under VPN, IPSec tunnels, and let's try to create a new IPSec tunnel. In this wizard, it can walk you through how you can configure the VPN. I always like to go with custom so I can configure everything myself. And right now, as I am in the original site, I want to build my VPN to my new site. So I want to call this VPN to new site. Save it like that. This is the main configuration menu for an IPsec VPN. First, it's going to ask us for the protocol. We are using IPv4. In here, it's going to ask you which type of address is the endpoint you are trying to connect to. This will be the public IP of the firewall on the other side, which is going to be the new site public IP address. Also, if you notice, once you open this list, you will see dynamic DNS. This is the option we configured on the FortiGate on Edge episode, where we configured a dynamic DNS on the modem. And we mentioned we can use it to configure VPNs to public IPs that are constantly changing. So this is the option you want to use if your IP is changing all the time. If you have a static public IP address, the option you want to use is static IP address. So for here, I want to put the IP address of the other side for my new site. And the interface where the public traffic goes through is internet, port 1. So I want to use the internet interface. We don't need anything else in here. Second step is to configure our authentication. In order to establish a VPN tunnel, you need a pre-shared key. It's like a password that is used to communicate between the two firewalls on each side. For this, I recommend using a hard password, using a password generator of some sort. So you can just go into password generator and use something in Lindsay password. So I want to use something like a 40 character with all these symbols and things like that, and that will be my tunnel password. So I want to generate multiple ones. I want to use this one, and this will be my tunnel password. In this section, you will be asked which IKE version you use. Now we have two main IKE versions. We have the old IKE version number 1, and we have a newer version, IKE version number 2. And IKE version 2 is a newer version of IKE protocol that allows more optimization to the VPN negotiation process and less overhead on the firewalls when negotiating a VPN tunnel. Now, this option is not supported in all platforms, but in this case, since we are using the same exact model, we can move into version 2 as well. In this side, we see our proposal, and we have a phase 1 and we have a phase 2, and those are core components of any VPN tunnel. First, the phase 1 dictates how the encryption and authentication will be configured on this tunnel and how long the phase 1 timeout will be in seconds. And then the phase 2 allows you to configure which networks are allowed to talk on these tunnels. So in the phase 2, you configure the boundaries of your VPN tunnel. On phase 1, you configure the encryption and authentication. So in here, we have only one option in the trial version, which is DES. This is very weak mechanism to configure. Usually you would see an option in a real firewall for AES-256. This stands for Advanced Encryption Standard, and it's much more secure. But for the purpose of this lab, we will use DES since we don't have any other option. Now you can also configure it in a way where you configure different parameters such as SHA-1, SHA-256, and from there the firewall will negotiate the highest encryption method between the two firewalls, and it will go from there. But if you want to force it to use a specific encryption and authentication method, you just leave one liner and choose which option would you like. So I want to go with SHA-256 with DES. I want to leave this to 86400. And for the Diffie-Hellman group, you usually want to remove group number 5 and just leave it to group number 14. 14 is the minimum recommended Diffie-Hellman group to use within a VPN tunnel in 2020. So we want to leave this to 14 and we want to leave the timeout to 86400. Remember that all these parameters need to match exactly between both firewalls in order for the tunnel to work properly. So now we finish our phase 1 proposal. We choose our encryption, we choose our authentication, we deleted all the unneeded lines, we just forcing it to use that specific protocol for encryption and authentication. Now let's move into phase 2. And phase 2 defines the networks that will talk on that VPN tunnel. So let's go into GNS3 and try to figure out how we can route traffic between these two sites. Now we have a big issue on the new site because our IT administrator on that new site configured port 2 on the FortiGate to use for the interns network. And the issue is he used the same exact network we use on the sales network on port 2 on the original site. So now we have this host with 10.10.100.2 on the new site that belong to the intern department. And on the original site, we have a host with the same exact IP address on the sales department. So we have a conflict on IPs, and this will be an issue for us on the tunnel. So we will be looking into this issue on the NAT episode. But for now, let's try to route all the traffic that does not conflict between both firewalls through that VPN tunnel. So we know on the main site, we use 10.10.200.0/23 and a bunch of 192.168 networks. And also for our partner transit, we are using 172.16.0.0/30. Behind that, there are two networks. Since we have an internet connection directly on the new site, it's hard for us to set up a default route on this new site to route the traffic back to the original site because the internet traffic will be slow from the new site end user perspective. So we just need to route all these 10 networks and 192.168, and on the new site we only need to route this /23 for now, and we will leave the conflict network to be fixed on the NAT episode. So the first network we can route between the two sites is going to be the marking team. I see that it uses 10.10.200.0/23, and it does not have any conflict with the IP address on the new site. So this will be our first network on the original site. Let's put this address in here, 10.10.200.0/23. And for the remote site, we're just going to use the new network, 172.18.0.0/23. We expand the advanced version, we will also see another proposal in the phase 2, because we need to define the encryption on the phase 2 as well. And we can use the same options we used on the phase 1 and just remove all the unneeded option. And we will leave the group to group 14 only. And in here we have an option to set up auto negotiate and auto keep alive. Those will always keep the tunnel up regardless of traffic being traversing the tunnel or not. So we need to mark this. And we will leave the phase 2 timer. This is different from the phase 1 timer. And it's usually shorter in the period. So we'll leave it as the default. And we hit OK. So now we have a VPN tunnel on the original site between the 10.10.200.0/23 and the 172.18.0.0/23. Now we need to configure the same on the new site. So we want to go to VPN, IPSec tunnels, create new IPSec tunnel. And in this one, this will be VPN to my original site. And in this case, I will be using 192.168.1.121. This is the public IP address of the original site, port 1 interface. We will also use the interface for the internet. We will have to paste the same exact pre-shared key that we used on the other tunnel, and the IKE version must match, so we have to match all the settings. Use the DES with SHA-256, remove the other lines, remove group number 5, and in here it will be the same exact opposite of this local address and remote address, because in the original site the 10.10.200.0/23 is the local network, and this is the network that I will be reaching over the VPN. On the new site it will be the same exact opposite. My local network will be 172.18.0.0/23, and for my remote network it will be 10.10.200.0/23. Once we expand the advanced, we can also change the encryption again, remove all the unneeded lines, and remove port 5, enable auto negotiate and auto keep alive, and click OK. Now that I have the VPN built on both ends, I'm not seeing anything coming up so far. There are 2 more steps that we need to add to be able to route this traffic between the firewalls. First, we need to create a static routes on both ends to let the traffic know that it will use this interface to reach the other side. So from network static routes, on the new site we will be creating a route for 10.10.200.0/23, and for this we will route it into the VPN interface that we just created. So once you choose VPN to original site, click OK. Now we have our first route to the VPN on the new site firewall, and then on the original site we need to do the same under network static routes. We need to create a new static route for 172.18.0.0/23, and we will be sending this to VPN to new site. Click OK. The last step we need to do is we need to configure a firewall policy to allow traffic through the VPN tunnel. So come back into our original site here. I have my ping policy that allowed me to ping between all the interfaces. I should be able to create a policy or modify one of the policies I have right now to build this traffic. So let's create a new policy for this VPN traffic, and since I built this to the marketing network, the 10.10.200.0/23, I want to allow traffic from marketing to reach my VPN to new site network. And for the VPN, I can just create a new address object, and I want to call it my new site. And for this, the network will be 172.18.0.0/23, and click OK. So now I have my new site. I want to allow Bing also in the same way. I don't need to NAT this traffic because I'm routing this traffic natively between the VPNs. And I just want to log all traffic and save the policy. So now I have my first policy between the marketing and the VPN to new site. Now this policy will allow me to Bing from marketing over the VPN to the subnet on the new site. What if I try to Bing back from VPN to new site to marketing? We need a policy for this as well. But instead of creating a new policy and do the same thing, we can just right click on this policy and choose clone reverse. In this way, it will allow me to Bing from VPN to marketing. I just need to enable this policy. And now I have the same exact policy on the other direction. Now let's go to the new site and do the same thing. Create a policy coming from our analytics team, going into the VPN interface. We will choose our analytics subnet 172.18.0.0/23. Going into my original site 10.10.200.0/23. For the service, I will allow only Bing for now. I will remove the NAT and log all session. And then I will hit OK. And then on the policy in here, I want to right click into it and also clone reverse. And right click into this and enable this policy. Now, if I try to go under monitor, IPSec monitor, I can see my tunnel is up at this point. So right now I should be able to route traffic between these two firewalls and make sure that I'm able to reach everything on the other side. I want to go into my marketing PC. This is the subnet that I opened over the VPN, and I want to try to communicate with the analytics PC over this VPN interface. So let's try to come in here and do Bing 172.18.0.2. And you will see I'm able to reach the subnet on the new site, even though I have no direct connectivity between the two sites. And this is all happening through the internet, through the VPN. Now, if I try to Bing in the interface in here, and I want you to watch as I send the traffic, and we will see all this traffic is going under this ESP encapsulation. And if you try to open this packet, you will not be able to see anything inside because everything inside is encrypted using the DES SHA-256 encryption, and nothing or nobody on the internet can sniff or spy on this traffic. So now that we've verified marketing PC can Bing analytics PC, let's try to do the same the other way around. And on analytics PC, let's try to Bing 10.10.200.50. And now I can also Bing the other way around through the VPN tunnel. Now that we configured a functional VPN tunnel between this subnet and this subnet, we can also do the same for these additional subnets on design, IT, and HR. The good thing, since we are not using 192.168 space on the new site at all, we can summarize these three different networks and any future networks that we might build on the original site from the 192.168 range. So I want to show you how you can add multiple networks to the same VPN tunnel to be able to route different layer 3 networks. Let's go back to VPN, double click on the VPN tunnel, it's currently up. What we can do is we can create multiple phase 2 selectors under the same tunnel. So now we are only connecting our analytics subnet to our marketing subnet on the original site. We can add a new one as well. On the local address, we are still on the new site, so we will be using the same network 172.18.0.0/23. And on the other side, we can use 192.168.0.0/16. Under advanced, we can cancel all these unneeded lines and just choose DES, SHA-256, remove number 5, and enable auto negotiate and auto keep alive as well. We can give it a new distinct name, so we're just gonna call it phase 2 new. Hit OK. So now we have multiple phase 2 selectors or multiple networks riding this VPN tunnel. We have to do the same exact thing on the other side first. So let's head into our VPN IPSec tunnels and let's add a new networks on here. Call it phase 2 new as well. You don't have to match the name though. For the local address, it will be 192.168.0.0/16, and on the other side, it will be 172.18.0.0/23. We also have to match the same configuration as on the other side as well, and enable all the options. And once we hit OK, now we have our second phase 2 in here as well. So if we want to verify which tunnels are coming up, right now when it says up, that doesn't mean everything inside is up. It just means at least one phase 2 is up, therefore it has a good status. So I want to show you how you can do this as well. This is something that you need to do from the CLI because there is no GUI equivalent to it. So let's go into our CLI and we will be using a command get VPN IPSec tunnel summary. And once you put this, it will let you know that you have one VPN. This is the endpoint that you are connecting to. And under selector, this will show you all the phase 2 configuration. We have 2 configuration, of which 2 of them are up. We have everything is up on this tunnel. If you see an error in here, you must have mismatch one of the configurations between both sides. That's why you cannot see it. At the end of this course, we will do a troubleshooting and we will see what kind of troubleshooting we can do on VPN tunnels to discover why negotiation is failing or why you might have see a different number in here or might not see all the phase 2s up at the same time. And finally, we see the transmission metrics and errors, stuff like that. And finally, I need to adjust my policy to allow all these design, IT, HR, and partner subnets to talk to the VPN tunnel. So I just want to add my VPN interface to these policies. And on the new site, I just change all the IP addresses to all for now. Finally, we just need to add a static route on the new site for 192.168.0.0/16 to also go to the VPN interface. This way I have routes for everything. Now we can start validating our access using the VLAN trunks on port 4. So let's start by our design PC, and on here let's try to ping 172.18.0.2, and I'm able to ping from this subnet as well. On the analytics PC, let's try to ping 192.168.200.2, which is one of the HR PCs on the other side as well. And once it sends the ARP message, and it will be able to ping right after. So now we have connectivity between all these 4 subnets and our analytics PC or the subnet on this side. In the next episode where we configure NAT, we will be fixing the issue with the conflict IP address between the firewalls and also configuring our internet access for our clients in here. This is how you build VPN tunnels between sites and route different layer 3 segments between sites over internet in a protected, encrypted tunnel. Thank you for watching.